Okay, just a few other things I wanted to cover about drawing and selecting objects. So spreadsheets have a kind of different model than the other kind of graphical things for selection. You can click on a cell and drag through a set of cells. And you can actually get multiple regions in modern versions of spreadsheets by control clicking. And the main cool thing that spreadsheets have added is this little handle down here for extending the selection. Who knows what this little handle does? Does everybody know who doesn't know what this handle does? Really? Okay. So it's really an incredibly useful feature of spreadsheets. Let's see if I have a spreadsheet that's pretty innocuous. Okay. So if I have like 1 and 2, if you grab by the little handle, it extends in an intelligent way. Okay. So it will say 3, 4, 5, 6, 7, 8, 9, 10, like that. Right? If you have like 1 and 1, then you'll just get a lot of 1s. So, and if you just have one cell, then it usually doesn't know anything special, so it'll just do the same thing. On the other hand, if I have something like a date, 1/2/2014, and I try and extend that, it will usually, even from one example, it will extend the dates. Okay. And the other thing that people almost always do is if you have a formula, like if this equals this cell, oops, then it does that in an intelligent way. So this one will equal this cell, and this one will equal this cell, and so forth. Whereas if I just put the same value in all the cells, then all of them would refer to the 2 rather than to the corresponding cells. So this handle thing is really useful, and it tries to be intelligent based on whatever you start the selection on as you're dragging it through. So that's something everybody should really know about. Oops. And then finally, lists or hierarchies is another kind of set of things that you might select over. And examples are obviously the Windows Explorer, or the Macintosh Finder, which are file lists that are in hierarchies. And there's lots of other examples of hierarchies. If you do programming, then there's the packages and things like that. It's a standard way of doing things. Typically, in file hierarchies, you click to select one just like everybody else. However, you don't, just like graphical objects, you don't get to click and drag to extend the selection. Clicking and dragging moves like graphical objects. And you have to shift click if you want a region of objects. And similarly to graphical objects, if you can find a place that's not a file and you drag through, then you'll get to select in a rectangle. So that's sometimes tricky because they go to the margins. But if I select over here, then I can get a little box that I can select in a region. If I click on an individual object, I can't drag through because that'll start moving. But I can shift click. And in this particular browser, the shift click goes from wherever my original click was. Remember, we talked before about whether when you shift click, it always extends from the end or whether it extends from where you start. So those are two of the other options. And then in most file lists, you also have the option of control clicking, which toggles whatever you're clicking on in the selected set. So if I have something in the set, it takes it out and vice versa. So if I control click, then these will add, but I can do it in here and that will remove it. So, and obviously I can control click on something I just added in. So you get the option of individually putting things in and out. So very similar to graphical objects, but obviously entirely different feedback and different uses. So I wrote this cute little system quite a while ago that tried to provide for graphical objects a lot of programmability. And maybe I'll try and play that video. It's kind of fun. Let's see if I have the audio plugged. Here it is. Let's try the YouTube version. Oh, actually, the other one was, maybe this will work. The Topaz framework allows scripts or macros to be created by demonstration in any graphical application created with Amulet. All commands are listed in the undo window, and the user can select which command should be in the script. The commands do not need to be contiguous, in case some extra operations are performed by accident. The user can move which object is selected using keyboard keys, either forwards or backwards through the objects, and this can be recorded in the script by enabling recording of selection. Also, the user can search for the appropriate object. The values from the selected object can be copied into the search window, or values can be typed in. Which parameters will be used for the search are specified using the checkboxes on the left. The search can either go forwards or backwards through the objects, or else the user can search in a graphical direction, up, down, left, right, inside, or outside. This is useful for writing scripts like this one, that moves all objects that are on the right of the blue rectangle further to the right to make room. Parameters of operations can be explicitly generalized using dialog boxes. Topaz automatically generalizes any uses of objects that are created as part of the script. The generalizations of objects is specified and edited in this dialog box. For locations of objects, there are many options for each coordinate, with the icons representing relationships with other objects, such as that this object is to the left, right, above, below, or centered. The picture in the lower left of the window changes to show what is selected. This is a script to select the first object, duplicate it 3 times, and change the size to 3 computed positions with respect to the first object, and then delete the first object. Applying this script repeatedly subdivides the triangle. We can specify how many times the script is to be executed. Single stepping can be used to see what each of the operations does, which is useful for debugging. Scripts can be edited to delete commands or insert new commands. Another script goes through a list of numbers and makes rectangles with the width depending on the numbers to make a bar graph. Another feature of Topaz is that in addition to being invoked by keyboard accelerators, buttons, or menus, the user can specify that a script should be invoked before or after another command. The user just executes the desired command, selects the command in the undo window, and then clicks on the load button. The parameters of the command can be generalized. Here, we have created a script that puts a rectangle behind a string, and this is invoked every time a string is created. Topaz is a framework built into the middle layers of Amulet, and can be used by any application with little work by the programmer. Here is a script in a circuit program that performs the Morgan's law by changing an AND gate and a NOT gate into 2 NOT gates and an OR gate. Okay, so that was kind of fun. Project that I did a while ago. Which one was I doing? Nope. So the basic idea of this was to take kind of the conventional selection mechanism in graphical objects and the command object mechanism and generalize those in a way that could be used by a lot of different kinds of programs. And usually, selection is not put into the script, not put into the command history. It's not something you can undo. Like if you select something and undo, does Illustrator let you record those or undo them or anything?
Yes.
Yeah.
Certainly Photoshop does.
Okay.
If you do a marquee or something.
So sometimes these operations are hard enough that it would make sense to let people undo them. Okay. So the main topic for today was scrolling. And hopefully everybody is turning in their homework 2 on menus, and we're going to start on scrolling, the scrolling homework today. So the scrolling homework is very much like homework 1 in that you are going to evaluate different scrolling techniques with people. This time, since there are a lot of scrolling techniques and it only takes like a minute to test each one, it seemed like it'd be more fun to have you do more techniques. So in order to make it not a big assignment, you only have to do 2 people. So 4 techniques with 2 people, that's yourself and 1 more person who's not like you. Okay, so just to be clear, and you can do extra people or extra techniques if you want, like homework 1. A lot of people got a little bit of extra credit doing that. And so here are a bunch of different scrolling techniques that we're going to talk about in class today. Lots of different ways of moving content around. Obviously, I'm using 2-finger scroll, which is a little app for my PC here. All your Macintosh users are used to doing this. It's only recently that PCs have been able to do it. 2-finger scroll. But there's regular scroll bars, all sorts of things we're going to talk about. And similarly to homework 1, I have the spreadsheet, which nobody's filled out yet because you didn't know you needed to, where you're going to list the scrolling techniques, and hopefully everybody will spread out over lots of different ones like we did last time. That worked out really well. And if anybody thinks of any others that could go in the list, that would be great. So, these are all the ones I thought of, but if you can come up with something else, maybe some external device or a knob or something, that would be great. And for the experiment, we're going to talk at the end of the lecture about 2 different experiments that were done in the past. So let's say a 2-finger scroll. And so one of the experiments, this is based on an old experiment from IBM. This is a page from the IBM glossary or manual or something. And so make sure your subjects and yourself read the instructions at the top of the page. Okay, so the sample of first group of pages, scroll down as fast as you can until you find a link and click on it. The link will look something like this, **** next. So this is to simulate the situation where you're browsing for something and you don't know where it is, right? So somewhere down on this long page is a link, and I have to scroll, but if I scroll too fast, I won't see it, right? So I'm likely to scroll a little more slowly till I find it, and then I can click on it. So there's 10 of those. It takes about 30 seconds to go through them. It's really quick. The next set is another experiment that we did that tries to simulate the situation where you know where you're going. So this is, I'm in a really big document and I know I kind of want to go to the middle, or I kind of want to go to the end. Okay, so in this case, it says what line you're supposed to go to, but none of these are marked, so you can't do it visually. Okay, so you have to memorize what number I'm supposed to go on, 28 left. So you tell the subjects you have to memorize that. Then I scroll down until I find 28 left. And then notice it doesn't change the cursor when I'm over it even. That was tricky to implement. But if you press down and then click on 28 left, then you'll go to the next page. And if your subjects wants to try again, you can just use the back buttons. And they can go again. If you click in the wrong place, then nothing happens. Okay, so there won't be any way to measure errors in this experiment, unlike the click one that measured errors. And so you'll have to kind of watch carefully and see if the user seems to be clicking in the wrong place, or ask them, obviously one of your users is yourself, so you'll have to be, vigilant about whether you click in the wrong place at all, and, just basically do that informally. And if you go all the way to the end, 28 left, so then it says, okay, that was for practice, and when you're ready, you hit start, and then it starts a timer. And the timer, there's a timer on every page, and so you're supposed to scroll down and click. So it's page 1, page 2, page 3, and so forth. Pretty straightforward. Page 6. Okay. kind of boring to watch, but it doesn't take very long. I just want to get to the next section. They kind of move back and forth left and right. That was to try and avoid the bias, depending on if your scroll technique is a scroll bar on the right side of the window. So I'm using, and you want to make sure your subject uses the same scrolling technique for the whole experiment. Okay? And so now I'm supposed to click on 80 right. And 80 is the last line, so that's all the way to the bottom. 40 is more in the middle. In terms of screen size, you should make sure that 20 lines down requires some scrolling. That's like the minimum that it's using. So obviously, in this screen, I still have to scroll to get down there. If you end up putting with this enormous screen in front of people, then it might actually just be there. So then you'll want to make the window a little smaller to make sure they do at least a little scrolling. 20 left, 30 left. And so this particular part has four, wasn't it 25 left? 25 middle. It would probably be better designed if I had used frames so that you could see the target the whole time. What was it, middle? I don't remember, right? Yeah, okay, and then, so there was a bunch of small ones, and then there's a whole series of big ones. So if you remember, there are 80 lines, so 78 is way at the bottom, and obviously it's a lot faster. If you know where you're going, you can just go there quickly and not have to worry too much about being accurate. So you would imagine, again, I've forgotten which one I'm supposed to do, that people would scroll faster if they know where they're going. And then at the end, you get an output like the first one. There's the kind of table that's human readable, and then there's the CSV version that you can copy and paste into your own spreadsheet. Be sure to do this before you have the person do the next kind of scrolling, right? Because otherwise you'll lose it. A bunch of people last time said, "Oh, I forgot," and lost my my content. So you don't want to do that. So going back to the homework.
Was there a reason that you have sort of the?
Yeah, so you can see where you are. Otherwise, it's hard to tell that you're actually scrolling because they were all identical and the numbers are kind of little. So when my original design, and this I did 20 years ago, 30 years ago, it just had the numbers and you really couldn't quite tell. And sometimes there's the wheel effect that if you scroll at the right speed, it looks like it's going in the wrong direction because they're beating in place. So by having this big X, it makes it really clear that it's moving. That's a good question. And then we have a Google Doc where you're supposed to paste in the answers in case we get around to doing a little. We should look at the data from the first experiment. We haven't done that yet. Okay, so that's the homework. You're supposed to start now. You only have 2 weeks, just like number 2. So you don't want to wait till last minute. We need to be fairly strict on this one because I need to get your midterm grades in, and we'd like to have this as part of your midterm grade. So this is due 2 weeks from today. And the discussion, the report, again, is similar to the last one, where you're going to discuss what you used and compare it to these 2 experiments that I'll talk about in a minute. Any questions about the homework setup? Okay. So interestingly, I looked in a bunch of textbooks to see if they had a section about scrolling or sliders or anything like that, and they didn't. There's this enormous section about how to do menus, how to organize your menus, how to let people choose things, and there's virtually no discussion about how to let people pick numbers in a range, which is basically what you're doing with scroll bars. What I'm looking at here are all the techniques that have been used, but there's really very little guidance about how to design them, and there's not that many choices that you have to pick from anyway. Certainly, this has been something that people had to worry about since the beginning of graphics. And in the original Sketchpad system, we talked about all these switches that are being used for input, but we didn't really emphasize the fact that there are these 4 big knobs, and those are being used to control panning. Anybody people know what panning is? So panning, it comes from cameras. Panning is when you move the camera side to side. And so similarly, when you move the contents of your window side to side, up and down, that's called panning, because it looks like you're moving the camera and what you're seeing. Zooming, obviously everyone knows what that is when you go in and out. And similarly, it comes from video, where you can zoom into the contents. And these knobs were used to pan and zoom. But what about computerized techniques? And a lot of these shots were taken from the video because that's really the only record of a lot of the stuff that's left. So I'm really glad that I did these videos in the 90s when some of these machines were still working, because nowadays you'd probably have a hard time getting Bravo to run anywhere. And some of these level of details were really never documented in the standard material about these systems that you can find online. Or, when they wrote a paper about Bravo, they didn't talk about how you would scroll, because it really wasn't that significant in terms of how they were thinking of it. And it's not the way we're doing it now. So in Bravo, this was, as you remember, the first WYSIWYG text editor. And it was from 1974. And what happened was, if you moved your cursor into the left margin, which was this big white blank area, then the cursor changed to an up and down arrow, so you knew something different was going to happen. And if you pressed the left mouse button, it would scroll up, and the right mouse button, it would scroll down. And it's surprisingly not symmetric. So the left mouse button took the line that's next to the cursor. So if I did it here, it would take this line and move that line to the top. Okay? And if I hit the right mouse button, it would take the top and move it down to where the cursor is. So you might imagine that what that should do is take the line that you're at and move it to the bottom, right? Because that would be more symmetric, the line to the top or a line to the bottom. But it doesn't do that. So why doesn't the right mouse button scroll the line that you're on to the bottom of the screen? Maybe I'll call on somebody. That way we can get people to practice, to participate. Jack Butler? No? Samantha? Okay. Why? What happened? Why? Any ideas why the right button doesn't take the line you're at and scroll to the bottom of the screen? Would that work? Could you actually implement it to do that? I'm sorry, I couldn't hear. I'm sorry, can you speak a little louder?
Wouldn't the whole page go below the bottom of the screen?
Yep, certainly all of these have to be limited by what's on the screen. And so it doesn't actually go further than a screen full, so that's certainly one issue. But that would be true no matter which scrolling technique we picked. Suzanne? Okay. What's your idea for why the left and right don't do the same thing? Why wouldn't you want this right button to take the line that's next to the cursor and go to the bottom? Do people understand the difference? So left mouse, so if I put my cursor, say, right here, the left mouse button would move the word left to the top of the screen. And my idea is that the right mouse button should take the line I'm on. Where'd the cursor go? Should take the line I'm on and move it to the bottom of the screen. But that's not what they did. Any idea why not? Okay, you want to?
You have two lines.
Well, the idea of left and right going up and down at all, or the reason that you could change it, was that you could control how much you wanted to move. All right, so if I wanted to move just a little bit, I could put my cursor here, and it would move up just a little bit. And if I wanted to move down, in the idea where the right mouse button would move down, I could put it down here, and that would move down just a little bit. Or if I go up from the bottom, if I put my cursor here and go up, then it'll go page by page. So this technique does let you control how much you want to do, but I'm still trying to get at why these are not symmetric. Anybody? Yeah?
Well, they are symmetric if you think about how much distance in each direction, because both going up and down will move it the same distance, but just what direction it's moving.
Right. So the main point is that if I move it up and I realize that wasn't what I really wanted to do, then I can bring it back exactly where it was by hitting the right mouse button. And similarly, if I'm moving up a little bit and then I realize I overshot and I want to move down, then I can move down by exactly the amount that I was moving up. And so they actually tried it the other way, and everyone was really annoyed that if I'm up here, if I'm up here and I click up and I go up a little bit and then I realize, oop, I went up too much, and I hit down, in the other design it would go down a whole page. It would go down a lot because I'm at the other end of the screen. Whereas in this design, it just goes down the same amount it goes up. So it was a much better design, but it does kind of sound wrong when you read about it. And then the middle button did thumb, and so you get a little marker, which was a box to show where you are. So it would use like we're used to now, the whole side of the screen as the scroll bar, and it would show you what part of the file you're at now, and then you could move up and down, and you'd get this little triangle to show you where you'd go, and then when you release, it would jump there. Did we talk about why it's called the thumb? Why is it called the thumb? You want to have a guess? Yeah?
Because your thumb is what provides the grip when you're holding on to something.
Nope. Not really. Any other guesses? So it's from reading a physical book. So if you have a big, thick book, and you were going to try to find the middle, right? You would flick down with your thumb until you got to the middle. And so you're kind of using your thumb along the spine or the inside of the book to pick a particular place. So and your thumb kind of shows you where you are in the document. So now I'm in the middle, and now I'm at the end. So typically, this little indicator that we're used to in the middle of a scroll bar is called the thumb. Another term that we'll see come in a little later was the elevator. That kind of makes sense too, right? So it's kind of where you are in the building, if you think of this as a building. And then this shows you, what part of the building you're at.
How did this interact with the text cursor? Like in modern word processors, if you scroll somewhere and then you start typing and your cursor's still up above, it jumps back. Was that behavior present?
I don't remember exactly. This was a modal editor, if you remember. And so you had to explicitly go into insert mode. And what I don't remember was whether you could scroll while you're in insert mode, or you had to leave insert mode, scroll, and then re-enter insert mode. I don't remember that. And I don't think, it'll probably be hard to figure that out, but we could see if we can find something that gives some answer to that. But I would think there's no particular, well, yeah. And most modern editors either refuse to let you make the cursor be off screen or automatically scroll there as soon as you start typing so that you can always see what you're typing. There are some editors which will let you not see what you're typing, but that's pretty annoying. Smalltalk was the first system that I'm aware of that had these pop-up scroll bars. It had a more conventional scroll bar. And so, well, up there, I found at least one example that showed you what it looked like. And it was one of the ways that it showed you which window was the focus window, which window you could type to. Remember we talked about how in windowing systems you have to have one window that you can type to, and the window that you could type to would have a scroll bar. And it popped up to the left of the text area. And it also had a thumb bar, this little box here. In this version, it's a gray box. And, whoops. Let's stop that. There were 3 regions of the scroll bar, and you got a different cursor depending on which region you were in. So the left region, so this was always operated with the left mouse button. So only one mouse button, unlike Bravo that used all 3 buttons. In this one, the other buttons were used for these menus. And so the left mouse button was one you usually clicked with. So you could go up with the left button, with the left button on the right area, down with the left button on the left area, and then in the middle you would grab the thumb and move it up and down. And I'm pretty sure that it had the same rules as Bravo, that it would move up and move the line that you're at up to the top, or the top down to where you're at. And another thing that was innovative is, if you remember, the Bravo cursor was just a triangle, independent of how big the area was. Smalltalk had this percent to show you what percent of the file you're seeing. Right, so up there, the little box is showing you that you're seeing very little of this document. Right? Whereas this bar shows you you're seeing about 1/3 of the document. Right? We're all used to these proportional bars now. This was the first system that introduced that. What was going on in most computers with these kind of character terminals at the time was that you would use keyboard keys to go up and down, right? So there were arrow keys on every keyboard. The PC keyboards have page up and page down buttons that would go by screen folds. There's a variety of other scrolling commands. This is, again, the word star screen that shows you some of the commands that it had for scrolling. How many people use Emacs? Right? Then it has Control N and Control V and a bunch of other screen commands, VI users in Vim, and it has its own set of scrolling commands. So all of these character-based systems would have various mechanisms to let you scroll around on the screen just using the keyboard. So that's kind of the state of the art that people were used to. Oh, and there was often not a big distinction between moving the cursor and moving the screen because it would always keep the cursor on the screen. So if I move the arrow keys such that the cursor moved off the bottom, then the text would start scrolling up. So they didn't necessarily have a separate mechanism for moving the screens rather than moving the cursor. Okay, going back to the Xerox systems, we were looking at Smalltalk, and again, InnerLisp was another environment that they built at Xerox PARC. Again, that had a pop-up window on the left. But this one, instead of being, actually that's incorrect, instead of being there all the time on the focus window, in Smalltalk, whenever the window had focus, the scroll bar was there. In InnerLisp, you actually had to move your cursor towards the left in order to see the scroll bar, kind of like what we're used to today. Again, the thumbs showed the percent visible, the left button for scrolling up, the right button for scrolling down, middle button to thumb, and it also used exactly the same cursors as Bravo did. So slightly different than Smalltalk, which had these weird half arrows, but similar behaviors. So then we get a really big break, right? So we've seen the scrolling in Smalltalk and InnerLisp and Bravo, right? They're all on the left. They all have use multiple buttons. And then we get to, or multiple regions, to the star, where scrolling works entirely differently. So this is basically the beginning of the scroll bar as we know it today. It has arrows at the top and bottom. It moved it to the right And if you read the material you were supposed to read from David Canfield Smith's lecture, he said that the reason for that was to reduce the visual clutter on the screen, because there wasn't much going on at the right side of the screen, whereas at the left, that's where all the text was and where people's focus was and things like that. David talked a little bit about these arrows. He said that they pointed down because that's the direction the text moves. So let's see if I have some content that will scroll. So when I push, let's see, if I push the down arrow, the text goes up, but the scroll bar goes down, the indicator goes down. One way of thinking about what's happening is that you've got a view screen or the window, and the window goes down towards the bottom of the text, and so this pulls the window down so you're seeing more of the bottom. Right? If you think of the content as fixed, and I move my window up and down, right? If I move the window down, I see the bottom. If I move the window up, I see the top. And so in some sense, that's what this arrow is doing. So if you're thinking of it as moving the window where the text is fixed behind that, that would be one way to think about it. I don't think anybody thinks of it that way, right? Mostly you think about, I'm moving this hand or this thumb or whatever down to the bottom. But in the star system, they did actually some user research to come back. Uh-oh. Why is that not showing up? That's bizarre. Oh, there it is. Okay. They did some user research to show that people expected the arrow to point down because that's the way the text moves. They also, in the original star, had plus and minus buttons to move by pages. So there was a minus at the top and a plus at the bottom. And those would go up one page up or one page down. So you couldn't click in the trough like you can nowadays. Instead, you would click on those buttons. And the scroll indicator, the thumb, is a fixed diamond, so it was a fixed size, so it doesn't show you what % of the document you're seeing. And anywhere you clicked in the background would jump the cursor to that point. Right? So that's kind of useful. And so you could click somewhere and drag around if you wanted to try different places. One thing they found that they mentioned on the video is that when people would try to do that, it was very difficult to stay inside the scroll bar, right? Because it's a long, skinny region. And so they made it so that if you pressed here and moved outside a little bit, it would still keep following your mouse, right? And if you try that nowadays, that's still what happens. So if I press here and pull down, I can go outside and it still keeps going. But there's a range. See, if I go a little bit too far, then the scroll bar disappears, because that tells me it's going to abort and not actually follow me anymore. So it's actually quite a large area that's active for scrolling, but it's not the whole window. So you can get back to, you can abort it by going far enough. And the other thing they added, which is kind of bizarre that no one's done since, is that if you clicked with the right mouse button and move, it actually moved by percents. And if you clicked here, it would move by Windows full instead of by document page, right? So that was kind of a weird extension that they added. So the Lisa had a different design slightly. So they still have the page buttons like the star did, and the arrows. In this case, they switched directions. Now they're pointing up and down instead of down and up. And they still have a fixed size thumb. And so in the Macintosh, You remember the Macintosh had a much smaller screen. And so they decided that the page buttons were just taking up too much space in the scroll bar. And they wanted to come up with a way of letting you scroll by pages. But most people didn't have very big documents at the time, so scrolling by pages wasn't that important. You remember we had these really tiny screens. And so they made it so that, first of all, these auto-repeat when you push on them. So people could just press there and hold, and it would start scrolling automatically. And also that you could press in these gray areas. So this is called the trough. Trough is like a long, skinny thing that horses drink out of. But you could also imagine the indicator moving up and down in that area. And you can click down in this background area, and it will auto-repeat. So who knows what happens? Well, it's not very interesting in PowerPoint. When I click in the trough here. I just said it. What happens when you click in the trough? Okay, I'm going to call on people again. See who's paying attention. David? What?
I wasn't paying very much attention.
Okay, what happens when you click in the trough? Above or below the thumb?
Doesn't the thumb itself like jump to that region?
Incorrect. Who's next? Sean? It jumps by pages. Okay, so in all modern scroll bars, if you click in the background, it goes a page, up or down, depending on whether you're below or above the scroll bar. Let's see if I have, here's a really long document. So if I click on the thing, I can drag it, of course. But if I click down here, it's not going to go to the bottom of the document. It's going to go down one page. Okay? And if I click up here, it'll go back up a page. And that also auto-repeats. Let me make this smaller. So if I click and hold down, eventually it'll start auto-repeating. So what's an issue with this auto-repeat in terms of if I click here and want to go by pages, and then it starts auto-repeating, what's a user interface issue with that? Let's see who's next. Samantha? Auto-repeat is when it repeats by itself. So if you think of a key, like any keyboard key, if I press and release, I get 1. But if I press and hold, eventually it starts auto-repeating. Right? So it repeats by itself automatically. And almost in all keyboards are set up so that there's a little pause, which is often user settable, because like handicapped people do this by accident all the time, or elderly people. So you want to make it longer for them, but if you want a lot of M's, you just hold your finger on it. And the same thing true with arrow keys. So I can click once and it goes, or I can click and hold down and then it goes by itself. So the same thing's true with this arrow. I can click. If I click once, it'll go by 1. And if I click and hold, eventually it'll start auto-repeating. That's a good question. So the same thing happens when you're going up and down by pages. And if I had a physical page button, I could click on that. But when I'm clicking in the background and I start this auto-repeating, drag it up. So what is an issue that's going to happen if we let this auto-repeat? Well, say I wanted to go almost to the end of the document. This one isn't very long, but yeah, I know I want to go almost to the end of the document, so I start auto-repeating, and eventually, I might get close to the end of the document. There is a problem of overshoot. That's one of the big issues in all the scrolling techniques, and you should definitely be really looking for that in your experiment when you're doing homework. That people often will go past where they want to get to and then have to backtrack. Yeah?
Well, so since you're using a PDF reader, if I have a particularly nasty PDF, the reader's renderer will get bogged down and stop functioning while I'm trying to scroll.
Yeah. But that can kind of happen with any scrolling method.
Well, if you
Yeah.
jump, if you do a direct jump, then it only renders
Okay.
where you land.
Yep, I don't think that's particularly about paging, yeah.
Is it that the bar doesn't actually get to where you're clicking, it just gets to where it overlaps and it stops, so you're looking actually at the top of the page, whereas you're clicking on the bottom of the page?
Well, there's certainly the issue that if I wanted to go to a very specific part of the page, if I go by pages, it's not going to necessarily go exactly where I want. But I was actually looking at a different issue. If I wanted to go to a particular point, I would probably drag the indicator. One more person want to guess? Yeah? Yeah, so most systems go quite fast. When it's auto-repeating, you can't really see what's there. But that's not the issue I was going for. The issue is if you have the cursor above the indicator, it goes up. If you have the cursor below the indicator, it goes down. Okay, what happens if I press in the background and hold it down? If I press in the same place a bunch of times separately, eventually the indicator's under the cursor. Another thing that could happen, if I'm particularly unlucky, it could actually jump past the cursor, which I can't seem to get happen. Oh, there we go. So it can jump from one side of the cursor to the other. So I could actually have it being toggling back and forth instead of continuing to go up. So if you just implement this in a naive way, like what happens here, is it auto-repeats for a while and then stops. Right? So you can't use this to auto-repeat to the end of the document like you could with the arrow keys. Right? So it doesn't matter where in this trough I click to get a page behavior. I can do it there or I can do it down here. But if I wanted to auto continue all by itself, then it does matter where I click because it's going to stop doing that behavior when it gets to the cursor. And what we'll see a little later is some other system said, that's not a good idea. I'm going to push the cursor out of the way. Or I'm just going to keep going. You can imagine it just keep going, in the same direction it was going as you're holding the cursor, the mouse button down as it continues to the end of the screen. So, these are some of the finicky little details that make all of these interaction techniques feel natural to people, feel weird, depending on how you implement them, can actually have a big impact on how people think about these low-level behaviors. Whoops, wrong one. Which lecture? This one. Okay, so that's the thumb. So if you can see the whole document, it didn't display anything here. So it just popped up when you needed to scroll. And the window that doesn't have the focus window, remember on the Macintosh you can only operate on one window at a time. So if the window was in the background, then it would show a blank, it would show the scroll bar but leave it blank. If you remember the alternative reality kit that introduced this 3D look, in order to kind of go with this physical metaphor, he had a hand that would grab objects and throw them around, but you could also move the hand to the edge of the screen, like here, and then the whole screen would start moving in the other direction, right? So all you had to do is move to the edge, and then the screen would start scrolling. So there's no scroll bars on this thing. There's no particular evidence of how you get to one side or the other. All you have to do is move to the edge, and then it happens. What's a modern system where you move to the edge in order to scroll side to side?
Every single RTS game ever.
Okay, yep, right. So that most video games, as your character moves to the edge, the scene behind him moves in the other direction.
I'm just going to say games.
Same thing, yeah. Another one is, pictures in, Facebook. If you move your cursor to the right edge, it shows you an arrow you can click on, right? If you can get to the next picture and so forth. It doesn't move automatically like this one did, but it's the same general idea. So OpenLook was one of the few systems that tried to have a different design. And in OpenLook, the cursor thingy, the thumb, had the arrows on it. Okay, and so they called it an elevator, and they called this the shaft cable, the elevator cable. So if you know anything about an elevator, there's actually a cable at the top for most elevators. There is no cable underneath the elevator, so that's kind of non-physical, but you can imagine it on a big screw or something like that. And the elevator moves up and down along this cable, and the little, what they called cable anchors at the top and bottom actually jumped to the ends of the document. How can you jump to the ends of the document on the Macintosh? Standard Macintosh scroll bar? Yeah? Well, nowadays, yeah. Nowadays, you'd have to give a big flick, yeah, in the old days. Yeah, so there's some special accelerators like command click or something like that to go to one end to the other. On this one, they had a particular what's called an affordance, a thing you can click on to get to the ends. And the arrows are, instead of being at the ends of the scroll bar, are attached to the thumb. And so it's kind of like the buttons in an elevator, which are inside the elevator. If you want to go down, you actually go in the elevator and press down, and then you get to go down. And certainly, it kind of made more sense that the down arrow is at the bottom because that actually moved the thumb down. Yeah?
If you click and held the arrow, would your cursor disappear, or would it run into the cursor and then stop?
So that's an excellent question. What happens actually is that it moves the cursor with the arrow. All right. So even though you move your mouse to here, and my cursor is right here, if I press down, then the cursor actually moves with the arrow. So why does that work with a mouse? Are you?
There's no real match between the mouse.
Right, so a mouse is what's called a relative device, right? You're just saying move a certain amount in this direction, right? You're not saying exactly here. So whereas a tablet, like in a regular tablet, if I pointed with my finger at this particular point, it would be really weird if the cursor was not at my fingertip, right? So if this kind of interactions would not work very well on a tablet or on any what's called absolute device, where you're actually telling it what part of the screen to look at. So the touchpads on all these devices are generally used in relative mode, right? But I guess that one's probably not.
Most drawing tablets are absolute.
Yeah, so a drawing tablet will be absolute. If you click in the top left corner, the cursor goes to the top left corner, no matter where it was beforehand. Whereas on the touchpad, on the Macintosh, it doesn't matter if you click in the top left corner or the bottom right corner. It's only about how far you move that affects it. So, if I move if I put my finger at the bottom corner and move to the top corner, it's not like I'm getting from the bottom corner to the top corner of the screen. I'm just moving a certain relative amount. So in that case, it makes sense to move the cursor wherever you want. But at the time, there were very few absolute devices. Everybody was using a mouse. And so this seemed like a good idea. Nowadays, that would be really dumb. And of course, you could drag by clicking on the center of the elevator. So this was a very short-lived attempt. Nobody much copied this. It had this problem that it didn't work with absolute devices. And OpenLook itself was not very popular. The next, if you remember your history, Steve Jobs was kicked out of Apple. He formed his own computer company called Next, and it had its own design. And one of the things they were trying to do was make it familiar, yet very different. So they wanted to make sure that nobody who saw a Next machine would think it was an Apple machine. So they just did a bunch of kind of arbitrary design changes to make it look differently. And one of the things they did was they moved the two arrow keys to the bottom. So the arrow keys are now together like they were with OpenLook. So one of the advantages they touted is that if you changed your mind about going from up to down, you didn't have very far to move. Whereas in a conventional scroll bar, you have to go all the way from the top to the bottom. Similarly with Next, they're right together, and you can move from one to the other. We also get a proportional sized scroll bar, which at the time the Macintosh only had a fixed size scroll bar. And they didn't have this ability to click in the trough to page. Instead, you had to use the Alt key to click on the arrows. Another thing they introduced is the ability to drag more slowly. So one of the problems if you're in a great big document, which happens to me all the time when I'm looking at movies, is that I want to go back by a very small amount, and just even 1 pixel is too much of the document. And so to avoid that, they let you use the Alt key while you're dragging this, and it would basically ratchet it down so you could have a lot more control. And also the scroll bar moved back to the left side of the windows. So, back and forth. The next big thing to come along in terms of scrolling was the scroll wheel on the mouse. And so until 97 or so, nobody had scroll wheels. So it's a relatively new invention. And it was, according to Wikipedia, it was popularized by Microsoft. It was part of the first optical mouse that they added the scroll wheel, so it had a whole bunch of advantages. It was a very popular, fast-selling mouse, much more accurate than the physical mice that had come before it. And this scroll let you control, and this is from my current system. Currently, I have the wheel set to scroll by 3 somethings every click, right? So most scroll wheels click. I think there's one sitting here. This is not connected to my computer, but so most of these have a little click that you can feel, and this box controls. This would be 3 lines typically, 3 lines per click, but you can control what you want to do with that. Jeff tells me that there are now some mice that are smooth that don't have this click function, or that where it's optional you can turn it on and off, which is a little weird. But does anybody have a smooth scrolling one? Yeah.
I have one that's adjustable, and it changes by itself, and I don't know why. It's got a physical button that switches it back and forth, and it still changes by itself between my usage.
In different applications, or?
No. Like between, it must get bumped somehow
Okay.
during transit, but I always leave it on the key.
Click.
Yeah.
Who else has one? Do you use it smooth, or?
I have one similar to his, but it doesn't change automatically. But like I switch it to the smooth when I want to just flip through a really long document. I can just do 1 click and it'll just keep scrolling.
Oh, okay, so it has momentum.
Yeah.
Okay. Yeah, so the clicky ones don't have momentum. If you let go, they just stop immediately. So that's a big difference, as opposed to like the tablets that are all designed to scroll smoothly. Okay. Another thing is all of these wheels allow you to press straight down on them to cause a clicking kind of function. And it sounds kind of like the mouse buttons, so you can hear it clicking. And those are usually in the operating system set to be the middle mouse button, going back to 3-button mice, right? All of these mice are 2 buttons, PC mice anyway. And so pressing in the middle on that causes the middle mouse button, which some applications use for something or other. Of course, scrolling in Google Maps does zooming, which I find really annoying because I'm always trying to scroll and instead it zooms. What are some other functions that the scroll wheel is being usurped for besides scrolling?
In a lot of editors, if you hold a modifier key, it'll rotate the direction so you can scroll sideways.
Oh, okay. Yeah?
When you're on like a browser, if
Uh-huh.
you want to close it down, you just tap the scroll bar.
Okay.
You also have keep the scroll wheel tilted.
Oh,
Scroll
yeah.
side to side.
Yeah, so some of these actually have sideways sensors that, yeah, this one does, where it actually has a left and right as well. So what does that do?
You can scroll left and right.
Okay.
You can, just very often.
By increments, or do you have to roll it while you're pulling it?
So you hold it and it goes. It's like a joystick.
Okay, right, because it would be hard to roll it in the reverse direction. And there was somebody else? Yeah?
Before that, they might have,
Right.
that one will go all directions, go vertical.
Sure. Okay. So that's the scroll wheel. So it turns out there's yet another way to scroll that came in at the same time, which was rate-controlled scrolling. So one way to do this is with the pointing stick and the middle mouse button on the IBM laptops, or at the time now Lenovo laptops. So if you press this middle button and you pull this joystick, then the document will scroll in the direction that you pull. So if I pull down, then it'll scroll down. If I push up, it'll scroll up. And it goes, the speed depends on how hard I pull, right? And so I think that's still enabled on my laptop. Let me try it. So if I press down and push, then I can scroll at different speeds. And I get this little icon that appears in the middle. And, okay. Sometimes it also works if you press and hold the middle mouse button down. You can turn that on so that that will do this rate control this rate control scrolling. So you press it in and then pull the mouse up and down in order to cause this rate control scrolling to happen. And as we'll see later in some of the experiments, which we probably won't get to today, but on Wednesday, that the rate control scrolling actually is really very inaccurate, and most people don't like it. Does anybody use rate control scrolling? Nope. So it's not too surprising because it's really hard to control, and it almost always overshoots. So I only use it occasionally, like when I want to go to the very end of a document, or I just want to go down a couple of lines. You can sometimes get it to do what you want, but otherwise it's really hard to control. It's called rate-controlled scrolling because you're controlling how fast it goes. You don't get to control where it goes. You just say, move down slowly, move down quickly. Okay, stop moving. So the Palm Pilot had a very conventional scroll bar. I was looking around and I couldn't find anything about the Newton. So if anybody, actually I should just pull out my colleague's Newton and try it and see what happens. I don't think it had anything interesting in terms of scrolling. I haven't seen anything. In the Palm Pilot, it had a conventional scroll bar on long documents, and you could tap on the top or bottom or on the bar with the stylus. And it also had these two physical arrow keys that you go up and down. Yeah?
I had a Palm Pilot back in 2005. It was a Sony one. It had a scroll wheel instead of arrow keys.
Okay.
Except no applications were made for the scroll wheel, so it never did what Sony thought it would do, which was really weird.
Yeah, I mean, it seems like if you're going to add a scroll wheel, you should just make it send down arrows.
It did, but
Okay.
it's sort of applications that it's whether you can hold it down, and it's really hard to hold down, which is like it sends repeated ones,
Yeah.
and it just moves it slightly every time.
Right. So it turns out in Windows, when they introduced this, in terms of how this actually works, is that there's basically Microsoft added to the operating system a new event. So instead of sending down arrow, it actually sends a scroll event. And it was up to the applications and the widgets to handle that. And of course, they built the widget sets, so they added the scroll down command to the scroll bar and all the other things so that that would happen in all the applications. But Sony didn't have control of the operating system here, and so they couldn't force applications to deal with their new operations. The RIM BlackBerry, one of the key parts of their user interface was their scroll wheel, and it was on the very original RIM device, and they kept that for many years as the key interaction technique, which this basically one-handed technique of scrolling was always under the thumb. The idea was that you would hold this in your right hand, so if you're left-handed, you were out of luck, and then be able to activate things. So you could scroll up and down, and again, you could push in to select the thing that was selected. The screen was not a touch screen, so it didn't help you couldn't tap on things. You had to go up and down in order to get to them directly. So the two-thumb keyboard and the thumb scroll wheel was kind of the key design features of all the BlackBerries until the iPhone came out, pretty much. And then they had to copy the iPhone style instead of having this technique. So the Macintosh, when Steve Jobs came back and they switched to this more 3D style, then they totally changed the scroll bars. So where did they get this two arrows at the bottom from? Where do we just see that? On the Next, right? So Steve Jobs came back from Next to Apple, right? And he brought with him a lot of his operating system, a lot of his code and design sense. And so they copied, when they went to OS X in 2001, they moved both of the arrows to the bottom of the scroll bar. And they also have a proportional bar instead of the fixed size bar that they'd always had before that. So a major design change, a major look change going on between those versions. Of course, with iOS, as we'll see in a minute, they got rid of all the arrows and stuff like that because everything has to be finger-sized. And so they've been slowly copying all those design features to the Macintosh. And so nowadays, on the Macintosh, there are no more arrows on your scroll bars, and you really aren't supposed to use those at all. You can kind of click on them if you try really hard, but generally, how many people still click on scroll bars? All you Macintosh people? No? Nobody does? You do? Okay. So if you're careful, you can get into the area. They pop up, right, when you get in that general vicinity, and you can still click on them if you're careful. But most people just flick with the touchpad. So this flick to scroll came in with the iPhone in 2007. The actual behavior of flick to scroll is quite old. Apple did not invent the idea that when you flick. We've actually seen that on very old systems. I'm not sure exactly when that came in, but it definitely was many, many years before that. What the iPhone did invent is the idea of this bounce at the end of the scroll. And we talked about that in the first lecture, that when you get to the end of the list on the iPhone, it moves a little bit past the end and then bounces back. And the inventor, Bas Ording, gave a little speech that I was at where he talked about how he came up with this. And in their user studies on the iPhone well before it was released, they were seeing people being confused about whether they were at the end of the list or not. And they would just keep trying to keep going, even though they were already at the end. So he came up with this idea of this little bounce, where it kind of stretches and contracts, and there may or may not be some feedback to show you that you're kind of past the end of the active area. And so they have an important patent on this where you can expand it and go back. And that patent is this one. Here's a couple pictures from it. And this was actually one of the key patents in the big Apple-Samsung lawsuit. And so naturally, Samsung was annoyed by this lawsuit, and so they quickly changed their software, and all of Google's Androids now operate differently than this. Typically, they'll glow. Right? Does anybody have an Android phone that does something besides glow?
I have an HTC, and it does like this accordion thing, which is similar to this, but I guess different enough.
Okay. All right, so the question is, when you get to the end of the list, how are you going to show the user that you've done that? And there are obviously lots of design ways of doing that. If you're an interaction designer, you could think of all sorts of different things you could do. Apple came up with this one, which seemed to be very compelling, and other people did other things. Another thing that's really important about the Apple is that they take in all these functions, including the speed at which it scrolls as you flick, and the amount it bounces, and these are highly tuned, that they really are very natural. I was given an earlier Nokia phone that tried to copy the iPhone behavior, where they had not bothered to do any tuning. And you would flick and it would be like mud, right? It just felt really wrong, that they just hadn't bothered to do the iterative design and careful engineering to make the behavior seem really natural, like you get on the Apple and most other current products. So the kind of idea of designing an interaction technique is often followed by a really large amount of engineering to make it, all the parameters work in the right way, to make it feel natural. And that's one of the things that Apple has really definitely excelled at. It also stops immediately when you touch it. So if you see what you're looking for going by, you can immediately stop it and catch it. Okay, we'll stop there. There's a few more slides on scrolling, and then we'll talk about some other things next time.